To expand the logarithm, we're going to use three properties. The first one is that if you have a log of a product, a times b, this will be the sum of logs. Log of a plus log of b. If you have a quotient, log of a over b, this will become a difference of logs, log of a minus log of b. And anytime you have a power on the argument of a log, so if I have a to the n power, that power is going to become a coefficient of the logarithm. So these three properties can be used to simplify our original expression. So we've got log base b of the cube root of x y to the fourth over z to the fifth. So one of the ways that I can use these properties over here on the right-hand side is that when something is multiplying, it will have a positive coefficient. When something is dividing, it will have a negative coefficient. And I'm going to use those two properties to start with to break apart this log a little bit. Not all the way, but a little. So in the numerator, the cube root of x is effectively multiplying the numerator. So this guy's going to get a positive coefficient, log base b, of the cube root of x. Y to the fourth is also in the numerator. It's effectively multiplying and will also have a positive coefficient, log base b of y to the fourth. And then z to the fifth is in the denominator. It's dividing, so it will have a negative coefficient, negative log base b of z to the fifth. Something to think about right now is when you have the cube root of x, you want to remember that that has a rational exponent. It's x to the 1/3 power. So if I use the power rule here, log base b of the cube root of x, the power of 1/3 comes out to the front as a coefficient on the log, log base b of x to the first, plus the exponent of 4 becomes the coefficient, log base b of y, and likewise the exponent of 5 becomes the coefficient here, 5 log base b of z. And at this point I have expanded the log as much as I possibly can.